would say, for those who are not familiar where Namibia is, it's in Southern Africa. Namibia is in Southern Africa, and where we did our studies in Windhoek, almost in the central part of the country. So it doesn't look right. Windhoek is located in the central part of the country in a relatively dry, semi-arid region which receives about 350 millimeters of rainfall per year, whereas the potential evaporation is in the region of 3,000 millimeters per annum. So it's quite dry. So most of the rivers only flow during the rain season, maybe 2 months, 3 months of the rain season, and the other, it's rare, they are dry. And hence, water is quite scarce in this, for this city. So, for water supply, the city of Windhoek constructed this dam called the Windhoek Dam. And incidentally, just upstream on the throwback of this reservoir is the wastewater treatment plant for domestic sewage. And Windhoek, they separate their domestic sewage from industrial sewage, so that the domestic sewage is the only one that is treated, is the only sewage that is treated at this treatment plant. And it's released into this reservoir. And part of it is also taken up by a reclamation plant, which treats the water back to potable use. And some of it is also, some of the wastewater, especially that has been treated in digesters, and it has high concentration of phosphorus, is treated just downstream of the reclamation plant at this point, and is pumped back to the Windhoek city for irrigating gardens. Hence, because it's an arid region, some farmers at this point and also at this point have decided to use this wastewater or effluent for irrigation. Then the concern among the population of Windhoek is the vegetables that are being irrigated in these gardens. Are the vegetables safe enough for consumption? So that was the basis of our investigation. And the other issue is this reservoir has now been polluted to such an extent that this reclamation plant prefers to take water straight from the maturation ponds from the wastewater treatment plant instead of this reservoir. And it is this same water that is being used for irrigation, and hence the quality of that water is not really known if it's very suitable for irrigation. That's what we wanted to find out. So we would say that was the problem, that the Polytechnic reservoir was decommissioned as a wastewater, as a source of water for treatment by the Windhoek wastewater reclamation plant due to its poor quality, but the water released from the polluted reservoir is used for vegetable irrigation in this semi-arid environment. So, is the effluent suitable for vegetable irrigation? That is what we wanted to find out. Hence, we did the following tests. We did in-situ tests for these parameters, and we also took water samples and did some tests in the laboratory, and we tested for E. coli, biological. We also did nutrient tests in the effluent, did soil for salts and heavy metals. We also did some calculations on the salinity of the water to check, and these are the sodium absorption ratio, the soluble sodium percentage, and also exchangeable sodium percentage. We also compared the results to WHO, FAO, and South African guidelines on irrigation water quality. And these are the results that we got. For turbidity, it was ranging from 6 to 15 NTU, and the recommendations according to FAO is it should be less than 5 NTU, but this is greater than 5 NTU, which means in terms of turbidity, it didn't meet the standards. Pathogenic organisms can still hide within particulate material within this water. The pH range ranged from 6.9 from 3.9 to 6.1, and according to FAO and South African guidelines for irrigation water quality, you can see it's too acidic. It was too acidic. Then electrical conductivity was measured and was found to be less than the recommended, according to the guideline, which means in terms of salinity, it's expected that this water is of relatively good quality. And we also measured for E. coli, and we found out that at 2 positions, position 1 and 2, which were the points where water was being abstracted for irrigation, the E. coli levels were acceptable mainly for vegetables that are cooked. But incidentally, the farmers are growing crops like carrots and one called Chinese cabbage, which can be eaten, some can eat them raw. So they are dangerous. Then at a downstream position, which is I call position 3, which is here, down here, we found out that the E. coli levels have risen well beyond recommended values. And for all samples, the BOT was less than 10 milligrams per liter, which is also within the acceptable levels. So we tried to find out why, when the water exits the dam, the E. coli levels are well within some acceptable levels. But just down here, they are well above. So we saw that probably this area, this part of Windhoek, is a residential area, and mainly it's informal settlements, which are not connected to the conventional sewer system of Windhoek. And they also use that part of the river for washing cars, washing clothes, and things like that. So probably that's where some of the contamination occurs. Then another possibility may also be because this part is an activated sludge treatment plant, mainly for the wastewater that is coming from the digesters from this upper. So probably it's also contributing to the high E. coli levels. So which means downstream here, from this point, the water is released into another reservoir. From that reservoir, the water is pumped and treated for supplying Windhoek. So which means the quality of that water again is quite questionable in terms of E. coli levels. We also tested for total nitrogen, and we found out that it was less than 30 milligrams per liter, which is okay according to the guidelines. Total phosphorus is greater than 2 milligrams per liter, which is above the recommended. Then, one other issue that also came out is that we found out that potassium is about 30 milligrams per liter, and if we use this irrigation rate of 1,000 to 15,000 cubic meters per hectare per year, we'll be dumping about 292 kgs per hectare. And most crops, this is well above the demand for the crops that are grown there, which means the possibility that potassium, the possibility that potassium can still be an environmental problem is there, even if we use this water for irrigation. For heavy metals, we found out that all heavy metals that we tested for were less than 0.01 milligrams per liter, which was fine. And mainly it's because this wastewater is derived from domestic return flows. So that's why we had a low heavy metal content. Then on salts, we found out that for salinity issues, SAR and SSP and ESP, they were within acceptable limits. Mainly, I would also say because we have high levels of potassium and also high levels of magnesium and calcium to counteract the concentration of sodium. So, will this scenario remain the same? The balance may change. We never know. So, we would say as a conclusion that this semi-treated effluent is generally suitable for irrigation, especially when the vegetables are eaten cooked. But the concerns were on the acidic, the water is acidic, high potassium levels. We don't know what's the impact they may have, this potassium, on the health of the river. Then the high concentration of sodium and calcium and magnesium. At the moment, they are within the levels acceptable, but will it remain the same? Hence, careful irrigation management is required for example, for flushing out these from the root zone, so that you have a long-term sustainable irrigation system. Also, another issue is the high turbidity and high E. coli levels, especially downstream of the irrigation systems. Those were areas of issues of concern.
Right, thank you very much.
Yes.
Okay. Questions?
Thank you. It's interesting. My question is about the acidity. The acidity is very low. What's the source of the acidity? And if you, I'm sure that you know that the acidity will affect the mobility of the ions, and this will decrease some of kind of the NPKs, because hydrogen, the acidity, that means the concentration of the hydrogen is high. So the mobility of it will reach the others and be on especially on the clays and something like that. So what's the source of acidity and how it will affect the planets? Because it's not only the water. Now we are speaking about acid environment and the roots. Okay, thank you.
Yeah, our guess is that the acidity should be coming from this, as the water passes through this reservoir. The reservoir, to be frank, it's green in color. That's how polluted it is. If you throw a stone, the bubbles will come out as green. They are green in color. So there's high organic matter content in that reservoir. So we expect probably the decomposition of those organics leading to some acidic environment. That's our case. We have not investigated really what is the component which causes the low acidity, high ions of hydrogen. Yes.
The geology. If it's natural, what's the geology of that?
The geology, I would say, it's a mixture of quite a number of, there's schist. That's the main predominant rock material that is there. And the others are not, but the schist is the main predominant. Yeah, the detail of geology. I'm not a geologist.
Right, any questions?
Sorry for asking a question. I know that Namibia also really uses wastewater for drinking water. The Windhoek, yeah? You directly inject the treated wastewater into the drinking water system? In
Yes.
Windhoek?
Like I said, this wastewater treatment plant here is the one that all the domestic wastewater is treated, and then there's a pipeline that connects to this reclamation plant that is here. And after reclaiming this water, it's pumped back into the system. It's mixed with the freshly treated water in the ratio of about 30 to 70, where 30% is the recycled water.
So
Yes.
my question is, what is the percentage of wastewater recycled? Like the 100% or all wastewater treated is recycled, used, or only a portion is used?
Like I said, it's 30%
30% is rejected.
is recycled.
Recycled.
Yes,
And
about
seven-
33%, yes.
And the 70 is for irrigation.
70 is allowed to flow downstream
Okay.
into another reservoir.
Thank you very much, Andrea. One of the most forgotten parameters when it comes into reuse of treated wastewater is Helminthi's X. Helminthi's X, because normally they have the impact to the farmers working on the field. Did you have an opportunity of just trying to look into that?
Yes, we looked into Hermes, there were no Hermes, so I was trying to just point on those parameters that were quite a bit outside expected.
Just one more question. The treatment for the wastewater is primary, secondary, tertiary, or quaternary? Because you are using it later on for drinking. So what's the level of treatment?
Okay, let's start with the wastewater treatment plant, because that's part of the treatment, isn't it? Here, there is mainly activated sludge and trickling filters. Those are the main treating units that are there. From there, it comes into this reclamation plant. There are multiple areas that are used there. The first one is ozonation. Then it goes into flocculation, mainly dissolved air flocculation using ion-based flocculants. Then again it's heated with after that it's taken again. Ozone is introduced again. Then the next point is filtration, sand filtration. Then the next point again is ultrafiltration. Then after that, chlorination.
Right. We got run out of time, so thank you very much. Okay, let's move on to the next.